Hi, welcome to Unit 3 on collecting data for AP Statistics. This video is going to focus on topic 3.6, selecting an experimental design. All right, we've learned an awful lot about experiments so far. Now that we know all there is to designing a successful experiment, we will look at 3 different ways an experiment can be designed. But before we do, however, understand that any design can be good or bad depending on the scenario, situation, and variables that are involved. So once we learn the 3 designs, you will really need to consider which is best for any particular research question. All right, so let's do a quick overview of the 3 designs. The first is a completely randomized design. I would compare this to a simple random sample in sampling terms, because you start off with all of your subjects and then you randomly pick who gets what. The second is a randomized block design. I would say that this is similar to stratified. However, we call them blocks. So remember, in a stratified sampling, you break your population down into groups and take some from each group. Well, in a block design, you block your subjects, or you break your subjects down into groups as well. And then you do an experiment within each block. So again, we'll talk more about that in a moment. And then a matched pair design is really an extreme form of blocking where you pair people up. And I'll talk a lot more about that at the end of the video. All right. Now, in order to help us understand the 3 different designs, I will use an example that I'm going to apply to each of the designs as we learn it. So to better understand each design, here's a research question. Does a new sunblock lotion dramatically reduce sunburn in people that are exposed to the sun? 50 subjects are ready to participate. So I need 2 treatment groups because I got to have comparison. So I'm already thinking, and this is the kind of stuff that you need to do before you select your design type. You got to think about what's your explanatory variable. Well, that's the suntan lotion. So I'm going to need a group that gets the suntan lotion. I'm also going to need a control group that doesn't get the suntan lotion. But I think I'm going to end up using a placebo, which is the fake suntan lotion. Because if you think about it, suntan lotion is basically like a liquid lotion that they, mostly a water-based lotion that they add a chemical in that actually blocks the sun. And I don't want that liquid to be a confounding variable, right? Because if you just think about it, there is potential that the actual sun is being blocked from the liquid base, not the sunblock ingredient. So what I'm actually going to do is I'm going to have a group that gets the sunblock. I'm going to have a group that gets a fake sunblock, which is just like a lotion that's water-based, but no active ingredient in it to block the sun. All right, the response variable I'm going to measure at the end is the severity of the sunburn. And now, before I pick my design, I'm going to start thinking, what are some things that can affect sunburn besides putting on sunblock? Well, for one thing, skin color. People of different skin colors could get burned more or less likely. Skin type, oily skin, dry skin, normal skin. Age, older people versus younger people. How much time are you going to spend in the sun? Obviously, you spend a longer time in the sun, you're going to get burned more. Pre-existing sunburn. So like if I already have a sunburn and I'm just going to get more on top of that, that could be a potential confounding variable. How much lotion is applied? Do you put a ton of lotion on or not a ton? And to what part of the body is applied to? Now, one thing I want to keep in mind is when you're considering working variables, you got to consider another one of our pillars, and that is control. Some of these things I can control for. For example, how much lotion is applied. I can control for that. I could give them a small tube and say, put this much lotion on, rub it on. Now, what part of the body is it applied to? I want to make sure I'm consistent with that. So I'm going to make sure everybody wears short sleeve shirts, and I'm going to have them put it on their forearms. They're going to put it on their entire forearm. So that's something that I can control for. That way at the end you can't say, oh, well, that worked because it was covered up. You used their chest. It was covered up by their chest with their shirt, something like that. So those are things I can't control for. Same thing with the pre-existing sunburn. I'm going to make sure that all 50 subjects don't have pre-existing sunburn. If I notice one of my subjects is already burnt from the sun, I'm just going to exclude them. I'm going to ask them to not, to step away and not be part of the survey. Now, the other things like skin color, skin type, age, I can't control that stuff either. I can also control the time spent in the sun. Once I have my subjects putting on these different lotions, everybody's going to go out in the sun for 1 hour. That way you cannot tell me, well, that person got more burned because they were in the sun longer. No, they were all in there for an hour. So it's important to always think about the things that you can control. And then now that we're going to learn these different designs, after you think about all that stuff, you could then say, okay, what design is going to be best for me? And hopefully by the end of this video, you'll understand that. All right, let's first talk about a completely randomized design. In a completely randomized design, what subjects get what treatment is completely random. So like I said, I compare this to a simple random sample because who gets picked, who doesn't, completely random. But here we have subjects, and it's about picking who gets what treatment. So the best way to do this is to give each subject a unique number, then use a random number generator or table to select the first X numbers. I left it X to be generic because it all depends on how many subjects you have. To receive treatment 1, the next X receive treatment 2, and so forth. I mean, if you have 5 treatments that you're going to give out and you have 100 people, well, then 20 will go into each treatment group. Another thing I want to point out is that if you do have an odd number of people, it's okay if your groups aren't identical in size. You could have a group that gets 10 and a group that gets 9. It's not the end of the world. Obviously, you don't want a group that gets 19 and another group that gets 1. That would be silly. All right, and then you also have to say that you're going to make sure you're going to ignore repeats and numbers that no one has. So oftentimes on an AP test, they will ask you, how are you going to actually do the random assignment? And this would be a great paragraph to write. Now, this is perhaps the most important thing I need you to understand when it comes to complete randomized design. All lurking and confounding variables that we could not control for will be roughly evenly dispersed amongst the treatment groups so that each group contains those lurking variables. Hence, they are no longer lurking or more biased. The idea is that if there's things that you can't control for, well, what you're going to assume is that those variables that you can't control for go into all of the treatment groups. And as long as they're in all the treatment groups, well, then your treatment groups are similar, except for what you give them. So you could essentially get rid of lurking variables by just having them randomly dispersed into all of your groups. And for some kids, they need to see an example of that to have that be understood. So let's do this one. All right, how could we make this work with our example? Well, here's what I wrote. I think this is a great explanation. After controlling for what we can, again, time in the sun, everybody gets an hour. Amount of lotion, everybody gets 2 ounces. Where do you put it? On your forearms. All right, after I control for all that junk, I would give each subject a number, 0, 1 through 50. Those are my 50 subjects. Then using a random number generator, I'm going to ignore repeats and numbers that nobody has. The first 25 numbers that get selected will receive the actual treatment group of the sunblock. The remaining 25 will receive the placebo, which is the water-based lotion alone with no active ingredient. Now, I'm assuming that I'm going to give them their tube unmarked, so that way it's completely blind. The subjects have no idea what they're putting on. Everybody thinks they're putting something on, so there's no chance for the placebo effect. Now, any of those remaining lurking variables, skin color, skin tone, skin type, age, I can't control for. I can't make people certain ages or have certain skin types. So what I'm going to hope for is that all of those remaining lurking variables are evenly dispersed into the 2 groups. So here's a little picture I have. 50 subjects, random selection, 25 get the treatment, 25 get the placebo. Again, if you truly do it random, you should have different skin types in both groups. You should have different skin colors in both groups, and you should have different ages in both groups. So you actually do have 2 very, very similar groups. And at the end, you could compare which group had more or less severe sunburn after the 1 hour. And a completely randomized design probably is the most popular and the easiest to use and understand. All right, the second is called a randomized block design. If you believe that there is at least one potential lurking variable that you just cannot leave up to chance to be roughly evenly dispersed into the treatment groups, then you could block. This is very much like stratifying when it comes to sampling, but now we're calling it blocking in an experiment. So what we're going to do here is we're going to create groups that we'll call blocks. And the subjects in each block have something in common. For example, I could put all the people with dark skin into one block, all the people with light skin, all the people with medium skin into their own blocks. So if I truly believe that skin color is the most important variable that I don't want to just leave up to chance, that's when I could block. Then you're going to go to each block, very much like stratifying. And in each block, you will run your own separate experiment. So I will go to the first block. Everybody gets a number. Half of them get treatment A, half of them get treatment B. If there ends up being 3 treatments, then A, B, and C, whatever. But again, that has to be done completely random. So within each block, you're running a mini experiment, completely randomizing who gets what in each block. This will ensure that that potential lurking variable is accounted for. hence reducing the variability within each block. Because each block is made up of only people with dark skin, well, now that they are very, very similar to what you thought of as was a very important variable. Let's talk about this with our example. I think it'll really help. So, once again, after controlling for what we can, time, in the sun, how much you're putting on, where you're putting it, I believe that skin color plays far too much a role for the severity of sunburn. I know that people with lighter skin get burned easier than people with darker skin. So I will first create blocks based on skin color, light, medium, and dark. I will then run a separate experiment within each block. In the light skin block, each person will get a unique number. Then using a random number generator, ignore repeats or ignore numbers that nobody has, the first X number selected will receive the actual treatment of the sunblock, and the remaining X will receive the placebo. Again, I'm just using X to be generic. It all depends on how many people you have. And then again, repeat this process over and over and over again with each block. So I'm going to repeat it in the light skin block, the medium skin block, and the dark skin block. You don't have to repeat the whole process 3 times. You will just say, I will repeat this process for the medium and dark skin blocks. Now, this will reduce the variation within each block, making the groups even more similar. So if you're in that dark skin block, you are very, very similar. But what I'm going to do is I'm going to go to everybody in that block, half get the treatment, half get the placebo. So now, at the end, I'm guaranteeing that some people with dark skin get both treatments, some people with light skin get both treatments, some people with medium skin get both treatments. In a completely randomized design, there is a chance, there is a big what if. What if all the people with dark skin go into the sunblock group? And that's why it looked like they had less sunburn. It was because they have darker skin. Well, if it's truly completely random, that should not happen. But if you are that concerned about it, that's when you can block and guarantee that it won't happen. So here's a picture of blocking. Got my 50 subjects. I create my blocks. I purposely made the sizes of the blocks different because, again, you can't control how many people have light skin, medium skin, and dark skin. So if I have 22 light skin, 11 randomly get the treatment, 11 get the placebo, 5 and 5 for the median, 9 and 9 with the dark skin. And again, if you do have an odd number, it doesn't have to be perfectly even. You could do, for example, if I had 9 instead of 10 in the medium skin, I could do 5 and 4. That would be totally fine. And again, this guarantees me light skin in both treatments, medium skin in both treatments, and dark skin in both treatments. So blocking will allow more clarity in my results. In each block, I will have even more reduced variation to really see if it's the sunblock that's working, not the color of their skin. Now, no one can say, oh, the sunblock worked only for those people because they have light skin. Nope. Sorry, each treatment was given out to each skin color, so I'm essentially getting rid of that as a lurking variable because I planned for these blocks, hence everybody's getting the treatments, or every skin type is getting the treatments. All right, the last design we have is called a matched pair design. Technically, a matched pair design is a special case of randomized block design. So some people might not list matched pairs as a third design. They kind of lump it in with blocking, but I think of it as a third design because it is so specialized. Here, we use several variables. Subjects, people or not, are arranged into pairs matched on several relevant factors. So you make pairs with your subjects, and you pair people together based on several matching factors. The 2 subjects in each pair should be as similar as possible, so a very small block that have several variables in common. So essentially, you're making small blocks. You're making a whole bunch of blocks, and you're going to put 2 people in a block, in a pair, because they have lots of things in common. And then what you do is every pair receives both treatments. So you're going to go to each pair, randomly assign one treatment to one member, and subsequently the remaining treatment will go to the other member. So in each pair, somebody's getting treatment 1, somebody's getting treatment 2. So since there are so many variables are controlled for and held constant in the pair, the only deciding factor to change the response is the treatment given. So if I have these 2 pairs of people that are so similar, and one of them had A and one of them had B, well then I could really say, wow, look at A, it really worked. You can't blame it on anything else because the only difference between these 2 people was A and B. All right, So a couple more things on a matched pair design. You could only have 2 treatments. If there are 3, 4, 5, 6 treatments, a matched pair design is completely out of the question. You cannot do it. I know that people say, well, can't you just do triples instead of pairs? And the answer is no, not in this class, at least I won't allow it. Now, keep in mind, each pair must receive both treatments. Some people accidentally think that one pair receives both things, meaning like each person gets treatment A. No. In each pair, somebody gets A, somebody gets B. That's how it works. How could you decide who gets what? Well, you could give numbers. There's only 2 people, so use numbers 0 and 1. Ignore all other numbers, and then use a random number generator. Whatever number comes up first, get treatment A. The remaining gets treatment B. Or you could flip a coin. So somebody's heads, somebody's tails, flip a coin. Whoever gets heads gets treatment A. Remaining person gets treatment B. Whatever. You should also blind them if possible. You don't want the 2 subjects knowing what they're receiving. So you might not, you might pair them up, but you never tell them that they're a pair. You just give this to that guy and you give the other thing to that guy. You never even tell them that they were a pair in the first place. That way they have no idea what they're getting. Now, there is a very special case where you could actually pair subjects together with themselves, and each person gets both treatments. Now, this is kind of hard to do for people because, for example, if it's a pill, I can't take one pill, make it work on my left half of my body, take another pill, make it work on my right half. Just not possible. And even if you say, well, take this pill week 1, take this pill week 2, the problem is that you already took pill 1, so that could potentially be confounding with the results from week 2. So you don't want to do that. Typically, we could do this type of design if we're working with inanimate objects maybe, or animals. Even animals, it's hard to be honest. But if you're working with objects, inanimate, not alive objects, you could sometimes give them both treatments. But we're going to actually explore how this is actually possible with our example. All right, so now let's actually apply this. All right, once again, after all those variables that we can't control for, controlled for, but if you think about it, oh man, skin type, age, skin color, there's lots of variables, and I think they're all important. So now I'm going to create pairs. I will pair 2 people together that are the same age, same gender, same skin type, and same skin color. So now I'm making several pairs. If I got 50 people, it's going to be 25 pairs. And they're so similar based on several factors, right? That's when you want to think about matched pair design. Then, in each pair, someone will get the number 1 and the other person will get the number 0. I will use a random number generator, ignore repeats that no one has, and the first person selected will get the active treatment, the actual lotion with the actual ingredient in it to block the sun, and the other will receive the placebo, which is my just water-based lotion, no ingredient. Now, that does need to be random. And again, in each pair, somebody's going to get the sunblock, somebody's going to get the placebo. I will repeat this process for all 50 pairs. Actually, I wrote 50 pairs. It should say 25 pairs. There were 50 people. That's 25 pairs. At the end, if the sunblock really worked for each person in the pair who had it, then you can't blame it on any other variables. Think about it. If of the 25 pairs, whoever got the sunblock had less sunburn, well, you can't blame it on gender. They were both guys. Can't blame it on dark skin. They both had dark skin. Can't blame it on age. They were both the same age. All these variables that you could potentially list as lurking are no longer lurking because you made these awesome pairs, guaranteeing that both or many variables were controlled for. Now, another way, this is an alternate solution for this, is using people as their own pairs. Now, this would be possible with sunblock. So once again, after controlling for everything we can, I feel there's just too many lurking confounding variables. So I will pair each subject up with themselves using their right arm and left arm. Now, this pair, right? Like for example, my left arm, my right arm, this pair are exactly the same. Same exact age, same exact gender, same exact skin type, same exact skin color. You cannot tell me anything is unsimilar about these 2 arms. Then, for each subject, left arm will get the number 1, right arm will get the number 0. I'll use a random number generator, ignoring repeats that no one has. And the first arm selected will get the active treatment, and the other arm will get the placebo. Now, once again, you want to try to blind the people. So maybe you just give them, you're the one, you're the researcher, right? You're the one figuring out who gets what. And then you go to your subjects and you say, okay, You're going to put this bottle on your right hand, rub it in real well throughout your entire forearm. Put this bottle on your left arm, rub it in real well throughout your entire forearm. Or maybe you even rub it on them just to make sure that it is exactly how you want and you're controlling everything that you can. And then I will repeat this process for all, again, it should say 50 pairs. I had 50 people. Now everybody's paired up with themselves. That's 50 pairs of arms. At the end, if the sunblock worked for each arm in the pair that had it, then come on. It is clear that the sunblock works. I mean, if everybody's sunblock arm, whatever arm it was, left or right, it's going to be different for every single person. If everybody's hand that had the sunblock truly had less sunburn, well, then it's so obvious. I mean, you can't blame it on anything because in each pair, there was so much control going on. All right, here's the last thing I want to leave you with. Selecting the best design. There are advantages and disadvantages for each experimental design, depending on the question of interest, the resources available, the explanatory variable, possible lurking and confounding variables, and the nature of the experimental units or subjects themselves. So you have to decide, after thinking about what is the question, how many people do I have, how many treatments do I have, what are some lurking and controlling variables I can't do anything about, and then you have to make a decision as to what's the best design. So you really have to select wisely here. Now, I will say this. Anytime you feel that there is an uncontrollable lurking or confounding variable that is very noticeable, that's a clear sign that you should block. All right, guys, that's it for the video. So understand that there are the 3 different designs: completely randomized, randomized block, and matched pair. All of them are great, but again, it all depends which one you want to use based on your situation. All right, be ready to practice this and try to really decipher, what we're going to do is we're going to look at examples and you're going to decide what design is being used. And then we're going to give you a research question and you're going to pick what design is best and then run with it and design it. So be prepared to practice.